All right, welcome back. Today we are going to talk about performing a hypothesis test when we have two samples. And the key to this one is going to be finding the difference between those two samples and determining if there's a difference. What's the same as what we've been doing is we're going to outline all of our parameters. We're going to outline our hypotheses, talk about our procedure, and our new procedure is going to be a little bit different. We'll still check our conditions and we'll still find standard deviation and those sorts of things in order to derive a probability that allows us to make a conclusion. So let's start with the prompt. The prompt is this: the student council at a large high school. And I kind of want to point out that part of the prompt there where it says large high school. When they do something like a large high school, large corporation, large any sort of entity, what they're saying is our samples are going to fit that 10% condition, which is going to allow us to use the standard deviation formula. So kind of keep an eye on words like that when we have it prompts. That's going to help us with our 10% condition later. So the student council at a large high school is wondering if juniors and seniors are more likely to attend prom. So they take a random sample of 50 juniors and they find that 28 are planning on attending prom. They take a random sample of 45 seniors and 29 are planning on attending. So as we work through our state part of the problem here, we're stating what the parameter is. And in this case, the question here is kind of telling us, do the data provide convincing evidence that a higher proportion of seniors are going to prom than juniors? And we're going to use a 5% significance level. I'm actually going to fill that in over here. So our alpha is equal to 0.05. What is our parameter? Well, when we're determining if there's a difference between things, so is one higher than the other, what we're going to use is we're going to use a P1 minus P2 notation, and where P1 and P2 represents our true difference. And in this case, it's the true difference in proportions of juniors and seniors. Going to prom. So in our hypothesis, it's going to reflect this parameter that we're trying to measure here. So our H sub 0 in these sorts of cases where we're trying to determine a difference is always going to be that our difference is equal to 0. So there is no difference in the juniors and the seniors. And in our case, our alternative hypothesis is going to come from what we found our sample proportions to be. So let's kind of jump over to statistic here. Our statistic here is going to be based on two things. We're going to talk about our juniors, and our juniors had a proportion up here of 28 attending out of 50, which represents 0.56, so 56%. And our seniors had a proportion of 29 out of 45. So our statistic here, what we're going to be measuring, kind of bounces back over here. What we're going to do is we're going to do juniors minus seniors. And so then in our case, we're going to have our statistic at p hat 1, which you'll recall represents p hat is our sample proportion. So p hat 1 minus p hat 2, which is juniors minus seniors. So that's going to give us 0.56 minus 0.64, which the senior proportion was 0.64, if you represented that as a decimal. And so that's going to be a negative 0.08. So the question you need to ask yourself is, do we have enough evidence to kind of continue this kind of line of logic? Well, if there was no difference, we'd expect to see no difference in our sample proportions. So because we have this negative 0.08 difference, we sort of continue to kick the can down the line and run this test. So the name of the procedure that we're going to be running is called and I know you're thinking about the alternative hypothesis, just hold on to that for a minute. The name of the procedure that we're going to be running is a two-sample z-test, and it's a z because we're dealing with proportions still, for P1 minus P2. Okay, let's go back up to our alternative hypothesis for just a minute. Our alternative hypothesis is also based on P1 minus P2, but in this case, we need to determine, is it going to be greater than, less than, or not equal to? Well, take a look at our samples that we had. Well, our samples that we had turned out a difference of negative 0.08. And so our alternative hypothesis is going to assert that P1 minus P2 is less than 0, because that's the only evidence that we have. The only evidence that we have of anything is that our sample of juniors was less than our sample of seniors. So now we jump down to checking the condition. The first one that we want to check is that things are random. And that's going to allow us to make determinations about the population. And if we look up here, we see the words random sample and also random sample. So what we'll put here is for random, we're going to put in quotes, random sample. So that fulfills our criteria. Part number 2 is, does it fulfill the 10% condition, meaning these are independent samples that are being drawn, so there's independence with each sample. And remember, I kind of talked about at the beginning, when we have this large high school mentality, we are going to be able to say that 50 is less than 1/10 of all juniors, and that 45 is less than 1/10 of all seniors. So remembering that 10% condition allows us not only to use the standard deviation formula, but also it gives it its own, it doesn't give it its own identity. So it's such a small sample that it takes on the identity of the population. Third is large counts. And for consideration of this 2-sample z-test, we need to kind of sidestep, and we need to talk about a concept called p hat sub c. Now, p hat sub c is equal to the combination of P1 and P2. When we run a 2-sample z-test for the difference of proportions, we are going to combine the two of them, because what we're looking at is the overall percent of people who fulfilled the certain criteria. So in this case, it's the overall percentage of people that attended prom. And our p hat sub c in this case is going to be 28, which was our total number of juniors, plus 29, which was our total number of seniors, over our total number of people, which was 50 plus 45. So our p hat sub c in this case is 0.60. Why do I mention that? Well, when we get to our large counts condition, we are going to use our p hat sub c to determine if we have large enough counts to do this calculation. So our large counts is going to look like this. N1 times p hat sub c, which would be 50 times 0.6, which gives us 30. And we're also going to do N1 times 1 minus p hat sub c, remembering, of course, that p hat, like multiplying by p hat sub c is the probability of successes, meaning getting what we want, people that went to prom, whereas 1 minus p hat sub c is the complement to that event, people who did not go to prom, or the probability of not going to prom. And so that'd be 50 times 0.3, which is going to give us 0.4. I was looking at that kind of sideways. So 50 times 0.4, which is giving us 20. And so in both of these cases, those are greater than 10 and greater than 10. So they both check out. And just because we combine the two proportions into that p hat sub c doesn't mean we don't have to check the senior sample as well. So then we'll do N2 times p hat sub c, which gives us 45 times 0.6, and N2 times 1 minus p hat sub c, which gives us 45 times 0.4. And in both of these cases where we get 27 and also 18, Both of those are greater than 10, so we can put a big check mark there. So all three of our conditions are met. So now not only can we talk about the population as a whole, we can also use our standard deviation formula and assume that samples are independent. And we know that the distribution, the sampling distribution for our difference in our proportions is going to be normal. So let's jump down and talk about mean for just a minute. Because we tested this and it's all good with our conditions, we can then say that our mean of P1 minus P2 is equal to the difference in proportions from our H sub 0. And if you don't remember why that is, just remember that we want to compare the sample that we got to assuming that the null is true. So I'm going to write that above here. Assume null true, which was that there is no difference. And so when we draw our standard curve over here, we're going to put 0 right in the middle because that's going to represent the mean, meaning there is no difference. And we're going to put our sample difference on that curve and determine the probability of that happening purely by chance. When we come down to standard deviation, this is the second place where that p hat sub c is going to pop up. And so standard deviation of P1 minus P2, you'll recall this, we're going to take the variances of the two samples, but we're going to use 0.6 times 0.4 over sample size 1, and then 0.6 times 0.4. Of course, that's representing p hat sub c, and we're going to put that over 45. And when we do this, we get its value to be 0.101, and that's our standard deviation. Keep in mind right there, okay, use your p hat sub c to determine that that numerator in both of your variances. Here's where we make the money, right here on the picture. Like I told you guys, it's very important to be able to draw this picture. It's going to help make a lot of sense out of this. So this curve is normal because it was true by large counts, and our mean is going to be 0, which is the difference between P1 and P2. Our standard deviation, as we just calculated, is 0.101. So visually, we're going to represent in the middle, that's our mean. So we want to say that, yes, the null is true, 0 is the difference. Well, we also need to jump down and find a z-score that's going to help us represent. And just to kind of help us out as we're thinking about this, let me draw in where our actual, value is, right? Because the difference that we observed in our two samples was negative 0.08. So it's below 0, and it seems to be, if we just did a pure, eyeballing of that compared to our standard deviation, it appears to be pretty low there. But let's take a look. Oh no, wait, so it's 0.08 compared to 0.101. So it doesn't appear to be even one standard deviation below. But let's do our general formula just in case, and our specific formula, and find an exact probability for that. So our test statistic, which is another name for z-score, is equal to our statistic minus our parameter over our standard deviation. All these values we actually have already. What does that formula look like? Kind of an interesting note here. So this is actually on your formula sheet. So if you ever get stuck and you're like, I don't really remember this formula, it's actually listed very specifically on your formula sheet for the AP exam underneath difference of proportions. So Z, and it's really important to use this and to show it because that's going to help inform where your work came from. So let's say you get the answer wrong on the AP test, but you showed your work. They're going to give you some credit because you showed the general formula, showed how you filled it in, and then just maybe you happen to compute wrong or did your interpretation wrong, which you'll get some credit for that. So our formula is our statistic, which is p hat 1 minus p hat 2. That would be like what our proportion of juniors and seniors got, minus what we believe to be true. So the null hypothesis, and the way to write that in this case is P1 minus P2. So essentially the second parentheses is 0 in our case, but we'll calculate down there just in a minute. And our standard deviation formula here is our p hat sub c times 1 minus p hat sub c over n1 plus, and this is where this formula gets a little bit lengthy, p hat sub c minus, or times 1 minus p hat sub c, and then over n2. The good news is we already did this calculation, right? So we're just kind of putting that formula out there for show, to show our work. When we actually plug in all these numbers, we get that z is equal to our difference, so 0.08, negative 0.08, minus our null, which is 0, over our standard deviation of 0.101. When you do this division, you get negative 0.79. So think about what that means in context. We are less than one standard deviation below the mean. And so do you think that's going to give us a big probability or a small probability? And especially considering our alpha level of 0.05 or 5%, we know that we don't get down to the 5% range until we get like 2 something standard deviations below, and we're less than 1. So when we check out our table A, we realize that our z-score of negative 0.79 gives us a probability, when you look that up, a p-value of 0.2148. Okay, so that's like 21.5%. When we evaluate that next to the alpha level, we see that it's very, very high, very, very high compared to the alpha level. So our conclusion is going to be informed by that. But we got to put it in context, right? So assuming the null, which is P1 minus P2 equals 0, is true, there is a 0.2148 probability of getting P hat sub 1, because we're going to talk about our result right now, equal to negative 0.08 or more extreme. Purely by chance. And so that's the first part. So we just literally laid out our result there. And so then next we're going to talk about comparison to the alpha level, because 0.2148 is greater than 0.05. We fail to reject the null. And do not have convincing evidence that the proportion of seniors, there's a high proportion of seniors going. So because we fail to reject the fact that it's equal to 0, we can't say that it's not that. We have to say we have convincing evidence. We do not have convincing evidence that there's a higher proportion. So we're kind of convinced that that 0 could be the answer. So to write that out, and we do not have convincing evidence that a higher proportion of seniors are going to prom. Okay, guys, so that's the basic gist of how we go through this. So, you're not going to have these fill-in-the-blank spots on the AP exam, but as we kind of scaffold this and we walk through the process, be sure when you're laying out your parameters, you keep in mind that you have to define what you're actually talking about, so that way when you talk about your hypotheses, we know what P1 and P2 are. You lay out what we actually got from our sample, define the alpha level. definitely name the test, must check conditions, have to talk about our mean and standard deviation so that we can put them into our picture. And then when you do this formula and you do the standard deviation formula, find your z-score and get your p-value, really important in your conclusion to include your context and say very definitively, do you reject the null or do you fail to reject the null? And then what does that mean? So what do you have convincing evidence of? So those are the basic pieces of this 4-step process as we walk through. Now, just want to walk through some notes here. This is the second part, and so I've already got them filled in because it's really kind of what we had up above. And so you can fill in these notes. Good time to pause here, but I'm just going to talk through some things because we've actually already talked about most of these pieces up in that problem above. So our state plan do conclude model has these 4 parts, and just to distill it into this box, good time to pause here again, is just to talk about really what needs to be in each of those individual pieces. So in our state, we need to define what exactly we're talking about. So P1 minus P2 is the true difference in proportions. I have to say that word true. Then we lay out our H sub 0 and our alternative hypothesis. And an important note on the alternative hypothesis, you're going to have P1 minus P2, and it could be any of these 3 things. So it could be less than, greater than, or not equal to 0. Keep in mind when you use that not equal to 0, you're going to be dealing potentially with a two-tail situation. So you're going to have to talk about what is the probability and then multiply by 2. In our plan, definitely need to say what the plan is. What is the test that you're going to run? And very, very soon, we're going to talk about the calculator functions that are associated with those, and that's going to help you pick out those ones that you put into the calculator. But when you do this 2-sample z-test for P1 minus P2, must be sure to check conditions, and very, very important here. This is crucial. So really highlight this. You must make sure that you use p hat sub c. And just a note over here, so I can draw a little arrow. P hat sub c is both of the pieces together. So both the things that you sampled, so both samples kind of combined into one. That p hat sub c is going to go into your standard deviation formula, and it's also going to help you check that 10% condition, remember. So that p hat sub c goes into here, and it also goes into some of your conditions as well. So keep in mind that as true. And then your conclusion obviously needs to interpret your p-value and say, do I reject H sub 0 or do I fail to reject H sub 0? All right, let's talk about this check understanding. Here's the prompt. Would encourage you to pause here and try it on your own because you're going to be doing a state plan do conclude. But I've kind of already got it written out, so I'm going to walk through it with you as we go down the line here. Here's the check your understanding prompt. Do you sleep with a comfort object as a child? Do you still? No need to stuff that teddy bear from your infant years into your closet the next time you have a guest over. The odds are good that he or she has a comfort object too. A study conducted by Sleepopolis and OnePoll reported that 34% of adults still sleep with a stuffed animal, blanket, or other sentimental object. According to a survey, a random sample of 100 adults, a similar study based on a random sample of 80 children reports that 75% of children. So what do you think we're going to be comparing here? When I look at this prompt, I try to pull out, okay, what's my question that I'm asking here? And they really outline it here. Do these data provide convincing evidence that the proportion of adults who sleep with comfort objects is less than the proportion of children? So just look for a second. Just look back at your prompt. Is there convincing evidence that proportion of adults is less than children? Well, the adults had 34% and the children had 75%. So do we have convincing evidence? Well, we haven't done any math yet, but we definitely have some evidence. And that's kind of one of those key phrases, right? Do you have some evidence? Yes. Convincing evidence? No. Not until I do the test of proportions. So in our state, what do we need to include? Well, we need to define exactly what are we going to be testing. Well, we're going to be testing the difference in adult minus children proportion. So finding the true difference in proportion of adults and children who sleep with a comfort object. So in this case, we said P sub A minus P sub C, not to be confused with P hat sub C, which is that combination of the two proportions. But really making sure to outline, I'm going to be subtracting adults minus children. So the adult percentage minus the child percentage. Also, I need to list out my hypotheses. So my hypothesis is that there is no difference. That's going to be our null every time, is that we're going to say, let's assume there is no difference. And then compare the difference that we found in our samples to that potential difference of 0. And then because my p hat sub A is equal to 0.34, and because my p hat sub C is 0.75, when I actually take that difference, I get that it's pretty significant. And so I say, I really do think that it's less than 0. That's my alternative hypothesis, because 34 minus 75 is a pretty significant difference. That's a 41% difference. So it seems like adults are 41% less likely to have, there's 41% less people that have a comfort object. Define my alpha level here, just for my own self. And what I like to do is I like to have this p hat sub C. And what we're going to do is we're going to call that pooled. And the concept of pooled means this: you pool them together. And for now, let's kind of take this track. AP Stats is such a vacation. You want to be in the pool. So you are going to be in the pool of objects, meaning we're going to pool things together. Your calculator is going to ask you, do you want to pool or unpool when you run this test on it? But for now, we are just going to pool all of our data together and have that combined proportion. So I like to define that as p hat sub C. I did my addition here and got that was 0.522. Remembering that that's going to be something that goes into my standard deviation formula up here, and also when I check my 10% condition down there, just as a reminder. So here's my plan. That 2 sample z-test for P1 minus P2. And right below there, I just gave myself a little reminder, P sub A minus P sub C. That way I don't get confused and try to subtract something the wrong way. Checking of my conditions. Here are the 3 things. Is it random? So both samples had to be random. When I look up here, it says a similar study, a random sample of 80 children, and it was a survey of random sample of 100 adults. So I literally put in quotes, random sample of adults, random sample of children. Check and check. Okay, 10% condition. Oh, I think up here I said 10% condition for this. I didn't mean that. I meant for our large counts condition. Anyhow, 10% condition. So 100 is definitely less than 10% of all adults. 80 is definitely less than 10% of all children. So we can check and check those. I want to zoom in on this a little bit. Right there, you see it? Checking for normal. This is our large counts condition. I still have to check both the adults and the children, but I'm going to be using the pooled data. So p hat sub C is my proportions. So here's my p hat sub C right here. This is 1 minus p hat sub C. And also for the children, let me even label that. P sub A, P sub C. This is my p hat sub C, p hat sub C, and this is 1 minus p hat sub C. 1 minus p hat sub C, okay? All of those are greater than 10. We're dealing with really, really big numbers here. All of those are greater than 10, which means it's normal. So when I draw my curve, here is what I have. I would put my curve on here. I would know that it's normal. I'm going to put 0, which is my h sub 0 true value. True here. And then I haven't calculated my standard deviation yet, but we will do that in just 1 second here. Okay, so what am I going to do? I'm going to do this, find my z-score. To find z-score, I have to have my difference here. So this is my difference in my samples, and this is my h sub 0. This is going to be 0. Down below, keeping note, use my p hat sub C for all possible calculations because I want to compare it to the fact that the h sub 0 is true. And then when I find my z-score, I get that my difference, minus 0 over my relatively small standard deviation, yields a very large negative z-score. And as you know, when we use that 68, 95, 99% rule, when we get outside of 3 standard deviations, our probabilities are getting very, very low. And so we have a p-value of essentially 0. And you can say that. You can say, because it's equal to like 0.00002 or something like that, you can say that that's essentially 0. So when I put it on my curve up here, and I have my standard deviation, and I put that down here, keep in mind, this is a little bitty percent, very, very small there, okay? And so my conclusion is actually fairly simple, but I have to write it out with all of its proper context and all of its proper formalness. So assume that P sub A minus P sub C is 0. This is our null hypothesis, is true. There is essentially a 0% probability that I get this negative 0.41 purely by chance, which means, just to review, if it's 0 and I get this really outlandish value, there's not a high probability of that. And so purely by chance, I'm suspecting that my H sub 0 must not be true. So we have convincing evidence to reject the null because 0 is much less than 0.05. And we have convincing evidence that the proportion of children with comfort objects is greater than the proportion of adults. So I assumed there was no difference, saw this really big difference, found out that it was really unlikely to get that difference purely by chance, and rejected the null, okay? So that's how these two sample z-tests for P1 minus P2 work. If you guys have any questions, please feel free to reach out, but thanks for watching, and we will see you next time.